some more. So that would be 2c plus 3d times 2c minus 3d, and then I'm just going to bring down this factor right here, 4c squared plus 9d squared. So this is a complete factorization of number 13. Number 14, there is no GCF, but I noticed that this is a perfect square right here, and this is a perfect square. So I'm going to check and see. This is 2x to the third, and this is 8y to the third. When I multiply 2 and 8, I get 16. When I double it, I get 32, and that's exactly what you have right here. Okay, so the factored form of this one, this is a perfect square trinomial. You put a square up there and you're done. Okay, number 15 has a 5y squared as a GCF, so I take it out. And so I'm left with x squared minus 25. And this is a difference of squares, so you get 5y squared, and then x plus 5 times x minus 5. And that's it. Number 16. See, I have common factor would be x squared. Okay, so x squared, I could take that out. So that gives me 10 x to the third minus 4x squared minus 15x plus 6. Okay, now these four terms I'm going to put in the little box to see if I could, factor the way I usually factor, with a little box like that. And so I'm going to put 10x to the third minus 4x squared minus 15x 6. So the greatest common factor in the first row is 2x squared. So I'm going to take out 2x squared. And so you ask yourself, what do you have to multiply by 2x squared in order to get 10x cubed? So the answer to that is 5x. And same question, what do you have to multiply by 2x squared in order to get negative 4x squared? The answer is negative 2. And finally, what do you have to multiply 5x in order to get negative 15x? And the answer to that is negative 3. And you just check, is negative 3 times negative 2 equal to positive 6? The answer is yes, so you factored it correctly. So the final answer would look like this. X squared times 5x minus 2 times 2x squared minus 3. And that's the final answer. Let's see, number 17. Check to see if it's a perfect square trinomial, because I noticed that this number right here and this number right here are both perfect squares. So the square root of 4x squared is 2x. The square root of 9 is 3. If I multiply 2x and 3, I get 6x. When I double, I get 12. So yes, it's a perfect square trinomial. So I'm going to just bring down the plus and square. Okay, number 18. I can factor out, I can factor out an x, and you get 16x squared minus 40x plus 25. Now in the parentheses it looks like a perfect square trinomial, so I'm going to see. 4x and 5 are the square roots respectively. I multiply 4x and 5, you get 20. When you double, you get 40. Since that worked out, I bring down the negative from the 40x, put parentheses, square, and then just bring down the x that I had as a GCF. And there's the answer. It says divide by using long division, write the results. So we're going to divide 2x plus 4. (2x cubed plus 14x squared). So on this one there is no need for any placeholders. right? So we're not missing any terms. So then 2x times what gives you 2x cubed? That would be x squared. We multiply, so we get 2x cubed plus 4x squared. Now we subtract. So remember, when you subtract, you add the opposite. So we scribble out that plus and put a minus. And now we add, so this is 0. 14 minus 4 is 10. Bring down the next term. So 2x times what gives you 10x squared? The answer is 5x. So you get 10x squared. 5x, that's 20x. We're going to subtract. When you subtract, you add the opposite, so this is minus. Scratch that out, that's a negative right there. So you get negative 24x. Bring down the negative 48. So 2x times what gives you negative 24x? That would be negative 12. And so that gives you negative 24x minus 48. We're going to subtract, so we add the opposite. So this is plus and this is plus, the opposite sign. And we get 0 as a remainder. So our quotient is this one right here. This is the answer. X squared plus 5x minus 12. Number 20, same thing. We're going to set it up. X squared plus 3. Now this one we have to, it's all out of order, right? The first one, number 19, was in order, was good, but this number 20 is not in standard form. So the first one we write down is 3x to the 5th, then 2x to the 4th, then 9x cubed, 10x squared. There is no x, so we need a placeholder. So let me move it. Oh, it's not going to fit. Hold on. So let me see. Move it over a little bit. Alright, so there it is, barely fit. We had to put a 0 placeholder for x because there is no x in the dividend. So now x squared into 3x to the 5th would be 3x to the 3rd. So I'll just put it up here, 3x to the 3rd. And so you multiply 3x to the 5th, and then that gives you plus 9x to the 3rd. We're going to subtract, oops, this is an x, not a 5. We're going to subtract, so we add the opposite. And so that's going to give us 0 here, and actually gives us a 0 here. So we bring down the 2x to the 4th, and probably the 10x squared. So x squared times what gives you 2x to the 4th? That would be 2x squared. So that gives me 2x to the 4th right there, and 6x squared. We're subtracting, so I'm adding the opposite. It's a minus. So this is gone, and then 10x squared minus 6x squared is 4x squared. Okay, I could bring down the 0x and the 12. And so now x squared goes times what gives you 4x squared, that would be 4. So I get 4x squared plus 12. So now I'm going to add the opposite. So then this is 0 and this is 0. Oh, okay, so no remainders on either one of these problems. So here's the answer right here for number 20.